Today we're going to be talking about solving exponential equations. Now, a key property of exponential functions are if you can get the bases to be equal, try and get the bases to be the same base, and then end up setting your exponents equal. So if the bases are the same, then you can just set the x equal to 5, the two exponents. So our first equation, and this one's super easy. Try and get 3 and 9 to be the same base. And you always want to pick the smaller of the two numbers to be your base. So 3x equals 9 is 3 to the third, and that's to the fourth. Now remember your properties of exponents. You multiply those two exponents together. So we get 3 to the x equals 3 to the 12th. Now I can set my exponents equal x equals 12. The next example. Again, try and get them so that the base is the smaller of the two numbers, meaning 2. So 4 we know is 2 squared. So I'm basically just changing that 4 to 2 squared. And then you put the other exponent kind of on the outside. Now remember that what you want to do is you want to multiply those exponents. So we get 4x minus 2. Okay, so then from there, you set your exponents equal. So I set 5x equal to 4x minus 2. Subtract the 4x over, so I get x equal to negative 2. Now solving this exponential equation. This one's a little bit trickier because I've been saying try and get them so that both sides are the same base. And choose the smaller of the two numbers. What you have to realize is that 2, 1/2, I should say, (1/2) is the same thing as 2 to the negative 1. So try and get them so that they're a whole number. So if it's a fraction, try and get it so that it's a whole number. So I have 2 to the negative 1, and then 8 is going to become 2 to the third. Now take and simplify. So we distribute the negative 1 through, so I have 2 negative 3x plus 2. Distribute the 3 through. Now go through and set your exponents equal. Add the 3x over, so I get 15x. I subtract the 15 over to get a negative 13. So we get a negative 13 over 15. And you can just leave it like that. Because I made up the problem, it's okay that it's kind of a funky fraction. Okay, so don't get nervous if you get kind of a scary looking fraction. Okay, write an exponential function for the graph that contains these 2 points. Remember, our exponential function is y equals a times b to the x. And remember, here I have an x and a y, an x and a y. Now, a key thing, and I sure hope we're paying attention and not just fast forwarding through the video, there's a reason that they give you one of the points is 0 and 16. Okay, so let's plug that into our exponential. 16 is our y. We have a times b to the 0 power. B to the 0 is 1. So the reason they give us this point is this is also gives us what A is right away. So it's essentially cutting out a step. So they tell us right away that A is 16. So now let's again look at this. Y equals A times B to the X. And let's start substituting in. We have A is 16. So substitute A to be 16. I don't know what B is yet, but using the other point, I have an X and a Y. So I have an 81, and then I have B to the 4th power. I divide both sides by 16, and I would expect that you guys would use a calculator on this. I would be okay with that. And we get 5.0625. Now, I have B to the 4th equals that. We need to take everything to the 1/4 power or the 4th root. By doing that, we then get B to be 1.5. So therefore, now we know our A and our B. So we have Y equals A over here was 16. B right here was 1.5 to the X power. Okay. Another important application of exponential functions is compound interest. And I want you guys to know this formula. Compound interest is super, super important. And make sure you're writing this down because it tells you what A is. A is the amount after T years. So T is years, time. P is the principal, or what you put into the account. That's how I remember what you put in. P, put in. R is our annual interest rate. Remember, this is going to be as a decimal. And N is the corresponding periods per year. So we have an investment account pays 5% annual interest, compounded quarterly. 4,000 is placed in the account. Find the balance after 8 years. What I like to do in these problems is lay out what they're giving me. Okay, so looking at the problem, they're giving me 5.4% compounded quarterly. So our interest rate, our rate, is 0.054. Compounded quarterly, that's 4 times a year. So N is the number of times a year, N is 4. 4,000 is placed in the account. The principal, that's what I initially start with. And then after 8 years, okay, so I'm looking for A. What is the amount I'm going to have? Find the balance, the amount I'm going to have. So you might want to practice writing out the formula just so that you guys, it helps you memorize the formula, because I'm going to expect you guys to memorize that formula. Okay, so start filling in. I'm looking for A. Our principal is 4,000. I have a 1 plus our rate, 0.054 over N, which is 4. And then I have to the NT, so 4 times our time, which is 8. So now at this point, it's just a matter of plugging in your calculator. If you're super talented with your calculator, you can plug that all in at one point. What I recommend you guys do is first get what this piece is with your calculator. So go and figure out what that piece is. When I do that, I get 1.0135. Now, in your calculator, don't round until the very end. This is exactly what I got when I got this. Now, use the previous answer button. So, second negative sign, and take that to the 32nd power. Okay? And then take that previous answer and multiply it by 4,000. So, when I do that, you get a super exact answer of the amount we're going to have is $6,143.56. And I'm going to expect an exact answer on that, okay? So make sure that you're using the previous answer and previous entry and all that, those calculator buttons that are super helpful to us. Okay, there are your lesson questions. Please make sure those are submitted on time.